Hello. Today we're going to look at the use and misuse of significance tests. Now, choosing a significance level of 0.05, there's really not a sharp distinction between a p-value of 0.051 and p-value of 0.049. It's kind of silly that we have to draw a line in the sand somewhere where one we say we reject the null hypothesis and the other we fail to reject, when they're practically the same value. So when you're reading a study, don't just look at the interpretation, also look at the p-values, because the p-values are just as important as your interpretation. Statistically significant does not mean practical importance. For instance, there's a study that showed applying bacterial cream would decrease the amount of time it takes for a wound to heal. The mean time was 7.6 days with a standard deviation of 1.4. A group of 25 volunteers used this formula, and their mean healing time was 7.1. We should check to see if that's significant at a 0.05 level. Well, I did it all for us, so we could go through this quicker. We checked the mean at 7.6. Conditions that didn't really meet very well, but when we're doing the calculations, we got a 0.037. And from this, we reject the null hypothesis at the 5% level. So we have evidence that the cream reduces healing time. That's great. But if we look back here, 7.6 days and 7.1 days. Would you want to go to a store, buy some antibacterial cream, and then apply it and put bandages or whatever you need to do to tend to it for 7 straight days just to have a half a day reduction in healing time? In a case like this, you'd have to really look at how much pain you're in, because if you're not in very much pain, you probably wouldn't want to spend the time and effort to just reduce a half day of healing. So just because it was statistically significant that it reduced the time doesn't mean that we should go out and everybody buy this cream for whenever they get an injury. Now, it's always important to analyze the data. The interpretations are not set in stone. Make sure you take a broader look at it rather than just looking at the interpretations. Also, if a test fails to reject the null hypothesis, it doesn't necessarily mean that the alternative hypothesis is wrong. For instance, now sometimes we have a rejection area here, and we get a point out here, so we fail to reject this null hypothesis. That doesn't mean the null hypothesis is particularly true. It means we might not have just had enough evidence to reject this null hypothesis. It's possible that our changes increase the mean, but we just don't have enough evidence. So, so don't necessarily just think that the alternative hypothesis is wrong. So here, we also have to look out for taking multiple studies. A researcher looked at 30 different types of cancer and cell phone usage. She did significance tests on all 30 types of cancer and found that one didn't pass at the 0.05 level. Does this mean that cell phones cause this type of cancer? We should say no. How many would we expect for them not to pass? Well, if you do 30 different tests, all at a 0.05 level, 5% of the time you're going to reject the null hypothesis. So if you multiply that, that's 1.5. So if you do 30 tests, you'd expect about 1.5 of them to come back statistically significant, even if they aren't. All right, and that's the end of that video.